Hello and welcome to this How to Simplify Radicals video. Today, we'll be looking at 4 different types of problem, each of which involves simplifying radicals or numbers under a root at different degrees of difficulty. But no need to worry, I'll go through each problem with you step by step. A radical expression is just another way of saying that it contains a square root. Together, we'll use our math skills today, and by the end of this video, you'll be able to factor by finding perfect squares, simplify square roots with variables and exponents, both even and odd, simplify radicals with fractions, rationalize denominators so that the denominator of a fraction does not contain a radical expression. We will do this by multiplying and dividing the denominator by the square roots and by using something called conjugate pairs. We will also learn how to express answers in its simplest radical form. Let's begin. For our first problem, we have to find the square root of 60. In order to simplify this radical, you have to find the largest perfect square that will divide into 60. In this case, 4 is the largest perfect square. 4 times 15 is equals 60. The square root of 4 equals 2. So this leaves us with the answer of 2 radical 15 as the simplest radical form of this problem, since 15 cannot be simplified further. And that is your answer. The next problem is similar to the first one we did, only a little bit more complicated because it contains variables and exponents in the radical expression. The first step is to find the largest perfect square that can divide into 108. In this case, 36 is the largest perfect square. 36 times 3 equals 108. The square root of 36 is 6, which leaves 3 under the radical. Now, let's deal with the variables with the exponents. In order to simplify radicals with variables and exponents, you need to determine if the exponent is even or odd. For even exponents, you divide the exponent by 2 when simplifying the radical. For example, in our problem we have the x to the 6th power. To simplify this radical, we get x to the 3rd power the same is true with the next variable, y to the 4th, which simplifies to y squared. But z to the 5th is a variable with an odd exponent. In this case, you have to make it to z to the 4th times z. Now you can simplify z to the 4th and get z squared, with z still remaining under the radical. So, get 6x to the 3rd power, y to squared, and then z squared, and then radical 3z. So this is the radical in its simplest form. So this is your answer. Our next problem involves fractions with radicals, and it requires us first to find the product of square roots, and then rationalize the denominator. It might look difficult at first glance, but don't worry, we'll simplify it. The problem is radical 3/4 times radical 4/5. First, let's find the product of the numerators of the two fractions. The square root of 3 times the square root of 4 is the square root of 12. Now, let's find the product of the denominators of the two radical fractions. The square root of 4 times the square root of 5, which equals the square root of 20. But in order to find the simplest radical form for this problem, we find the largest number that divides into both the numerator, radical 12, and the denominator, radical 20. The number is radical 4. So you have to divide it by radical 4 over radical 4. Once you divide it, you get radical 3 over radical 5. But we cannot have the radical in the denominator, so we have to rationalize the denominator. We multiply the fraction by radical 5 and radical 5. The product property of square roots tells us that a radical times without itself is the number without the radical. So that would be, this would be 5. In this case, we have radical 5 times radical 5, which equals simply 5. In the numerator, we have radical 3 times radical 5, which equals radical 15. So the simplest form of this problem is radical 15 over 5. This last problem may look difficult, but we'll take it step by step to simplify it together. To simplify the fraction 8 divided by 3 plus radical 3, you recognize that you have to rationalize the denominator because it has a radical in it. To do this, we will multiply the denominator by something called its conjugate pair. You will have to multiply the numerator by the conjugate pair as well. In this case, the conjugate of 3 plus radical 3 is 3 minus radical 3. And then you have to do that to the numerator as well. You can use the FOIL method to rationalize the denominator first. For f, you get, first, you get 3 times 3, which equals 9. For O, you get 3 times negative radical 3, which equals negative 3 radical 3. For I, you get, so I is radical 3 times 3, which equals 3 radical 3. Finally, for L, which stands for last, you get radical 3 times negative radical 3, which equals negative 3, because you're multiplying the same radicals against each other. Remember, a radical times itself is just a number without the radical. Only for this case, it's a negative. To recap FOIL, first, outer, inner, last, 9 minus 3 equals 6, and the outer and the inner cancel each other out. Our denominator now equals 6. Turning now to our numerator, let's rewrite the fraction. So we have 8 times 3 minus radical 3 over 6. You multiply 8 times 3 minus radical 3. You have to use the distributive property and multiply 8 times 3 first, and then 8 times negative radical 3. So this equals 24 minus 8 radical 3 over 6. The radical expression still needs to be simplified by dividing the numerator and the denominator by 2. So this gives us the simplest radical form of this problem, which is 12 minus 4 radical 3 over 3. And that is your answer. I hope this video has helped you learn how to simplify radicals. Now you can simplify these radicals by yourselves. Thank you for watching.